In this video, we're going to take a look at functions. Functions are an important part of algebra, pre-calc, and calculus. If you remember, functions take in an input and map that input to a unique output. No input can have more than one output, although more than one input can produce the same output. So we have this thing, the vertical line test, the functions have to pass. That ensures us that every x has really only one y. We generally think of the x going in and the y going out. On a sort of simplistic level, or sort of conceptual level, I like to think of a function as a black box. So if you had the function f of x, you put x in, f is programmed to do something to that x, right? In math and algebra and calculus, it's usually a number, and it spits out an answer, f of x, which we usually consider to be the y. Okay? So, before we get into these specific questions here, you have a function f of x, which is the square root of x plus 5. You have a function g of x, which is 1 over x squared minus 1. Right? If somebody asks us to do f of 3, right, then you would plug in or evaluate, right, the square root of x plus 5 using the value 3 for x. You would get the square root of 3 plus 5. You get the square root of 8, which, maybe you would simplify to 2 square roots of 2, but that's the sort of basic idea. Right? Each function gets a name, usually FGH, although sometimes we use letters that make sense. If you were doing profit, you might use P of X, or P of C, if C was cost. But a function, when you see these parentheses here, it's not times, it's a function of an input. The output is a function of the input. Right? You put the value in, you perform some operations to it, and produce a valid output. Okay? Now, just to kind of so that's just sort of a little bit of background review information, but the importance for that is we're going to talk about things you can and can't do. Right? For example, with f of x, right, can I just put anything I want in for x? Right? And when you start doing that, you can sort of study it and examine it and explore and observe, right? And a lot of times that's good enough, but that depends on your ability to do that. It depends on also your ability to do that under a test environment, right? And it also can take more time to kind of look at it abstractly and just try to think about it. We want to come up with some sort of simple and repeatable procedures. So what you're going to start to learn and keep track of, if you haven't already, is when you learn new functions and operations, what are the restrictions, right? Can you add, subtract, multiply any numbers you want? Sure. You can add and subtract positives, negatives, fractions, whole numbers, zero, non-zero, right? But when you start dividing, right, we have a restriction. You cannot divide by 0, right? 5 divided by 0 is undefined. Square roots are another one of these functions that have restrictions. Any even root, right, can only take as input positive values. So when you look at f of x and we talk about the domain, right, the domain is the set of all inputs that the function is defined over, right? Basically all the valid inputs that are allowed to go in without causing a problem. I always make the analogy with, a microwave. You can put a lot of food into the microwave, but you can't put metal. Right? You can put a lot of different containers too. But, there's kind of a warning in the manual that says do not put these certain things into the microwave, and it's very similar here. Do not put these certain numbers into this function. Now, domains can be stated in a positive or negative sense. Don't put these in, or these are all the things that can go in. But based on the functions we have here, f of x and g of x, there are restrictions on both of these. Now, linear, polynomial, or odd root functions, the domain could be all real numbers, right? Don't worry about it. Knock yourself out, put whatever you want in. But when we look at f of x in particular, we'll start with that. When you see the square root, right, the inside is called the radicand, right? But the inside of the radical sign with an even root has to be non-negative. Non-negative is a little bit different than positive because 0 is neither negative nor positive. So when you say non-negative, you're including 0. So in this case, what's inside the square root, that x plus 5, it can be 0, right? Because the square root of 0 is 0, but it can't be negative. So it has to be greater than or equal to 0. Okay? So when you're looking for the domain of a function, you're really looking for things that can cause problems. Add, subtract, multiply, no problems. Right? Divide, yeah, we have a problem. Square roots, yes, we have a problem. You'll also learn exponentials, no problem. Logarithms, yes, we have a problem. Some trig functions have problems, some don't. So as you learn new functions and you refamiliarize yourself with them, you're going to have to also look at the domain restrictions that are inherent to those functions. Once you recognize and know what to do, it's just simple algebra, right? You treat an inequality the same as an equal to sign, the big difference being that if you were to divide by negative on both sides, then you would have to reverse the inequality. We didn't do that here. I'm going to write this in interval notation. You're going to do a lot of interval notation. You can always go to the number line in between. We don't really use close and open circles. We use the close and open parentheses, square bracket of the parentheses, and because of the equal sign right here, that's why I have this square brace instead of the open parentheses. Infinity never gets a square brace just because it's not a real value. It just goes on forever. Okay, so this would be the domain of f of x. As long as x is negative 5 or more, f of x can compute. If you try to put negative 6 in, you have a problem. Anything below negative 5. Now, for g of x, right, 1 over x squared minus 1, you have a division going on. And when you have division, what's in the denominator can never be 0. Okay? Now, a not equal to sign like this is the same as an equal to sign. I'm going to factor this, x minus 1 and x plus 1. It's a difference of squares. That tells me that x minus 1 can't be 0, x plus 1 can't be 0. So I know that x can't be 1 and x can't be negative 1. So this is a case where you could state these are the only two values, positive 1 and negative 1, that will cause you problems. If you have to do this in interval notation, right, then what you're going to do is say I'm going to go from negative infinity all the way up to negative 1, because that's what you reach first, and you're not going to include negative 1. Then you're going to go from negative 1 to 1, and not including either, and then you're going to go on from 1 to infinity. So in this case, you're including everything except the negative 1 and the positive 1. Since they never actually get included, they're going to sort of fall through and be left out. So, depending on the situation, how the question's worded, what your instructor's preferences are, this might be okay for the domain, but certainly if you're asked in interval notation, you would want to do it this way. Okay, so domain is always a tricky concept for some people. It's a word as opposed to, a math term usually. And, if you think about domain outside of the world of mathematics, we talk about kingdoms having domains, right? And those are the areas or the people that the kingdom rules over, which is very similar to what we're talking about here, right? This function f of x can only work on certain values. So you can sort of think of it that way if you have a tough time remembering it. Okay. Now for part B, you're being asked to do a computation, f of g of 0. Okay. Sometimes this is written using this open circle here, composition of functions f of g of 0. But if I see it that way, I almost automatically turn it into this. And what you'll notice over here is that the 0 is input to g, right? So you plug 0 into g, g does its work, produces a number, and then that value comes in as input to f. So you're always going to work from the inside out, and we're going to start with g of 0. So I'm going to figure out what g of 0 is, right? That's 1 over 0 squared minus 1, right, which is negative 1. Right? 1 over negative 1 is negative 1. Now I'm going to do f of g of 0, which turned out to be negative 1. Right? So make sure you see that this g of 0 here, right, got replaced by negative 1, and that's why I have f of negative 1 now. Okay? F of negative 1, I'm going to switch over to the f rule. Right? Negative 1 plus 5, that's the square root of 4, which is 2. Okay? It's not plus or minus 2, it's 2. Okay? Square roots are functions. They can't spit out two valid answers. The plus or minus comes in when you're solving a quadratic equation, which we're not. Okay? We're going to do the same thing for part C, work from the inside out, except we don't have a value, we have a function, right? So we're going to start by figuring out what f of x is, right? And f of x is actually the square root of x plus 5. Now, if there was a number there, we could plug it in and simplify it, but in this case, we can't. So f of x gets replaced by the expression x plus 5, and now square root of x plus 5 has to go into g. And this is where things start to get a little bit more abstract, but this is going to become an important part, as we'll see in the next example and later in the semester. We'll have to be able to plug expressions into functions. Okay. Now going back up here to where g is, right? If I had g of a, then I would just replace this by a, right? I would change all my x's to a's. If I had g of b, I would just replace this with b. So what I have down here is I have g of the square root of x plus 5, right? Whatever x you give g, it's going to square, subtract 1, right? It's going to square it, then it's going to subtract 1, and then it's going to divide it 1 by it, right? So we're going to do the same thing down here. We're going to take 1 over, we're going to take the x plus 5 square rooted, we're going to square it and subtract 1, right? So what I really did was where there was an x up here, instead of x squared, now it's this whole expression squared. Now the nice thing is with this particular example, right, is that when you square the square root, you're just going to get what's on the inside. So in this case, I get 1 over x plus 5 minus 1, which becomes 1 over x plus 4. Okay? So this is g of f of x. Now as far as domain goes, you can see here that x can't be negative 4, but you would also have the original domain of f attached, because first, before you can make it into g, you have to make it through f. So the domain of composition of functions gets a little more complicated. I just really wanted to focus on plugging expressions in. Okay? Which brings us to this question. This is a very common calculus concept you'll see. And it's basically what we just did, plugging an expression in for x. So over here, this very first thing in the numerator, this x plus h, right, it's taking the place of the input of f. So before I try to do this whole fraction here, I want to write out what f of x plus h is, right? Whatever x was given, you were going to square it and add it to itself. So what I'm putting in now is x plus h, so I'm going to square it and add it to itself. Now, some people have trouble working with letters instead of numbers. You're going to have to get used to that a little bit, but you know, one of the nice things is you don't actually have to do any arithmetic, right? You just kind of keep things as they are. H is h. Okay? Now, when you square an expression like this, a binomial, two terms, you're going to have to multiply the parentheses out. You're going to do FOIL, the distributive property. You'll get x squared plus xh plus xh plus h squared, right? Plus x plus h. Now I'm going to simplify. These two come together, so I get x squared plus 2xh plus h squared plus x plus h, right? And all of this takes place of this numerator here, right? So this becomes, well, the first part in the numerator, right? So I get x squared plus 2xh plus h squared plus x plus h minus, and now f of x, and I have to put this in parentheses because I need to subtract the whole thing, right, over h. Okay? Now, the minus out here is going to make it to both the x squared and the x, and if you'll notice, there's already a positive x squared and a positive x here. This is not unique or coincidence. This is going to be part of the process. You will see this every time when you do this a fair amount. If you want to write it all out and then combine like terms, you can, but if you know to look for it, you can hopefully see that this minus x squared will take out this x squared. The minus x here will take out the plus x. And what you'll also notice, which is not a coincidence, is that everything left in the numerator has an h in it, which will allow us to do one more simplification. Factor the x out. Factor the h out, right? And then, since you have the same thing top and bottom, you can divide by it, right? And you will get 2x plus h squared plus h. This is a big concept in calculus. It has to do with finding the derivative. There's a little bit more to it than this. But you have all the algebra skills before you start calculus to do this. This is just a way to kind of help get you back up to speed and give you something to look at when you get to this point. How do you plug x plus h into f of x? Okay? So again, you know, work on some of this. We'll take a look at more in the next video, and you always have this to come back to if you need more help.